At the University of California, Berkeley, just across the bay from San Francisco, a team of researchers has quietly pulled off something most people still don't know exists. They've released the complete blueprints for a full-size, walking, object-grabbing humanoid robot that you can build in your garage for under $5,000. No CNC machine, no custom circuit boards, no PhD, just a desktop 3D printer, a soldering iron, and about a week of your life. Every CAD file, every line of code, every print profile, open source, free, sitting online right now waiting for you to download. This is Berkeley Humanoid Lite, and in the next few minutes, I'm showing you exactly where to get the files, what to buy, and what it really takes to build one of the cheapest humanoid robots on Earth. Let's look at the Berkeley Lite Humanoid Robot website. This is what it actually looks like right here. As you can see, it's mostly 3D printed. There's also a lot of wires sticking out everywhere and some connectors here and there. And then the middle looks like it might have some aluminum there. And it's got a spot for your IMU and your computer, your battery, your DVD player, whatever you can put in the middle there. And then looks like it doesn't have a head, but I'd probably just put like a 32-inch screen on top of it. I would just mount that. Nothing bigger than that. That would just be excessive, but at least a 32-inch, maybe smaller, for the face and the head. And then, and then it's got some flat feet, motors on each of the joints, which you can actually assemble yourself. And I'll put links to all this stuff in the description. Let's see, here it is in action. It's solving a Rubik's Cube with its, as you can see, the hands are super basic. It's basically a servo, which connects to a couple of spur gears and opens and closes this claw. It's a very basic hand. I mean, it's functional, but looks like it's scribbling something on a piece of paper. Looks like you can walk it around on a leash, and you can separate. You could just have the arms if you're just into the, if you just want some arm action. You can do jobs with the hand. Let's see. All right, let's check out the bill of materials. So this is on the Berkeley Humanoid Lite docs documentation. And once again, I'll put all this in the description, links for everything, so you can check it out yourself and maybe build this yourself. Let me know in the comments if you decide to build this yourself. That'd be pretty cool to hear your stories, or I guess read your stories, whatever. Now, as you can see, they've got some rough estimates. These may be more or less depending on where you're at or where you source it from. Looks like they have a bunch of links to Amazon. I'm not going to click on any of these, but that's kind of nice that they kind of steer you in the right direction of where you can find this type of stuff, even if you don't get it from that source. And it looks like it's less than 5,000 total to build this humanoid robot. Alright. So that's good. I guess I should probably read out the stuff on the list here. So mini PC, so that's probably like a Raspberry Pi or maybe a Jetson Nano, depending on your level of expertise with Linux. I mean, Raspberry Pi is more user-friendly, but if you really know Linux, I guess you could use a Jetson Nano. You might have better results with that. That's a lot more technical. And then you need some kind of battery. And it looks like they recommend a battery too, so that's good. Usually a lot of these projects don't recommend the battery, but that might actually help. Of course, the battery depends on the motors you use and, your wiring and a bunch of other factors. And then, let's see, so some basic stuff. 3D print filament, of course. Some bearings. Then the actuators. Looks like you can build the actuators yourself. And so those are basically 3D printed and It does have a motor controller and a position encoder. So that way the position encoder tells your computer where the motor is at, what position it's at. So that way you can move it more precisely. And without that, you just kind of have to guess where the motors are at, and when the robot wouldn't operate very well without a position encoder. So that's one little extra thing you need in there to kind of tell your, like if you're using a Raspberry Pi, that would basically, the position encoder would send messages to the Raspberry Pi, and that would let your software know where the motor's at, so it doesn't, rip its arm out of the socket or something like that. Or, move too far, and, I don't know, there's a lot of things that could happen with a robot malfunctioning. Alright, let's not get into that. So, let's see, if we go into the releases, you can find the CAD models, and these are all on Onshape. But they also have another website here for, you can download a Bamboo Studio profile and download all your parts that way, or send them straight to your printer if you have a Bamboo printer, 3D printer. Or there's also some different options here. You can download them as a 3MF, or you can download it as STL or CAD. That's going to require a sign into this site, Maker World. That's where they put these STL files. But there's also another option. If you check out the GitHub, so basically their GitHub is just some Python scripts, and these will export the Onshape design as a URDF or MJCF file, and you'll be able to view it with OpenSCAD or MeshLab. So let's see. So that's OpenSCAD right here. So OpenSCAD is a free software for solid 3D CAD objects. So that's for creating, 3D CAD objects. And apparently you can use it on any kind of system, Linux, Windows, Mac, all that good stuff. And then also MeshLab. So MeshLab, this is also for viewing 3D triangular meshes, or processing and editing of unstructured large 3D triangular meshes. Blech. So basically that's for looking at 3D objects. So if you want to convert those files and run it on your system using that, you basically install those on your system, OpenSCAD and MeshLab. Then you run these Python scripts that are provided, and it'll convert it automatically to these file formats if you prefer. But I think it's easier just to download the STL file and put it on your 3D printer, print it out that way, or edit it using your favorite CAD software. But if you want to check out OpenSCAD, the link will be in the description. I've never used it, so I don't know how easy it is to use. Maybe I'll make a video in the future on it. But for now, we're just going to focus on this humanoid robot. Alright. So, and then the Onshape link. Let's check this out. So that will open Onshape. And this is basically, you can view the robot right here. You can check out the whole thing. You can highlight things. You can move it around. You can modify it. You can export these. You can actually export the robot, the whole thing, all these different parts, has all these different file formats, STL, 3MF, URDF. You can actually do that from Onshape as well if you prefer. If you just want to use this this web interface right here. And there's a bunch of other options down here. You can look at the robot, zoom in, zoom out, check everything out. And as you can see, it's pretty much all 3D printed, except for a couple things, but those are basically bolted into the 3D prints. And so there's a couple motor controllers and a encoder, position encoder on each motor, so that way the limbs don't tear themselves apart. It looks like down here there's some motors in the feet as well, or for the ankles. Okay, so that kind of gives it a more natural gait. It has like an ankle, has some degrees of freedom in the ankle. But all right. Let's see, getting started with the hardware. We already checked out the bill of materials. Preparing the tools. Let's check this out. What do we got here? Alright, so we're going to need a 3D printer, soldering iron, so you can connect all your electrical components. That's the thing, if you want to build your own actuators, you're going to have to solder together, all the wiring. And more than likely, you're going to have to extend the wiring. That's going to require, some, what do they call that? We're going to have to splice the wires together. And then, you get the heat shrink tubing. If you really want to make it nice and clean, that's going to be a pain. But yeah, so you're going to have to do the wiring yourself. You're going to have to do all the software yourself. That's a whole nother story. Right now I'm just focusing on the hardware. And then you just need it recommends a glue gun. Okay. And then hex tool set for all the screws. So you're going to need a bunch of different screw sizes, M2 through M6. Those are different metric sizes for screws. And let's see here. Then it's got some instructions for 3D printing. So that's good. Nice. Some recommendations for how to 3D print everything. And then building the actuator. There's actually a nice little video right here for how to build the actuator. And so as you can see, you're actually literally splicing your wires on there yourself. Or soldering the wires, onto the PCBs. And then they actually have to attach the magnet to the shaft of the motor rotor. Wow. So you're actually modifying the motor itself. You're actually building a motor. So yeah, if you do this project, you'll be building your own motors, your own actuators, and a full humanoid robot. And these are actually really good instructions as well. I've seen a lot of instructions, and these are actually very decent. Very clear. Alright. And then after you're done with that, once you put your robot together, you gotta set up your motor controllers or flash through motor controllers. So you gotta flash the firmware. So there's instructions for that, which we're not gonna get into the flashing of the firmware and the software and all that. But it's all here. Links will be in the description. Alright, building the robot. Oh, and it even has instructions for how to assemble the different arms, legs, and the entire robot. So, check this out. Wiring. Alright. Oh, this is what I was talking about earlier here. Alright, so you're going to have to extend your wires at some point, so you're going to have to splice them together. And that takes some time. It's fairly easy to do, but it does take some practice and some time. And then connecting those, that's really a pain. Well, depending on what kind of connectors you have, it might be easier or more difficult, but and then so yeah, it's got a bunch of recommendations. So, and then we get to the software, which I'm not going to cover too much in this video, but looks like they do provide some training environments. I think you're kind of left on your own though for the software. You pretty much have to create that yourself. It may be out there somewhere though. You may be able to download an open source humanoid robot software that can work on your Berkeley Lite 3D printed robot. But let's see here. And it's got some simulation stuff. So if you like running your robot in simulation, you could do all that. Coming soon. We're not going to look at that. In-depth contents. Alright, so that's pretty much it. There's some more in-depth stuff. And then it looks like it runs on a CAN bus. The CAN frame is designed to mimic CAN Open Communication Protocol. Okay. So this is a little more complicated then, because so I guess this depends on your computer and the motors you use, but the motors they recommend need to be communicated through CAN, and so you're going to have to probably create a Python script that can translate your commands into a CAN instruction, and then I'm sure there's something you could plug into a Raspberry Pi to send, CAN communications. But I'm not going to look into that too much in this video, but I'm sure it's fairly simple to connect that to a Raspberry Pi somehow. But that's beyond the scope of this. I just wanted to present the hardware, show you how to get the STL file so you can 3D print this. You got the bill of materials, so you can get all the stuff you need, source all the parts, however you get it. Yep, I think we could pretty much wrap that up. And so, yep, that's all, folks. That is the Berkeley Humanoid Robot. So, if you like this content, please go ahead and subscribe and leave a comment. Let me know if you're going to build it yourself. And that's all, folks.